Good morning, Liran.
Hello, Brian. How's it
Hey.
going?
Not too bad, not too bad. To stay in my own ecosystem, I have my second cup of Java, and
There you go.
I needed that. Um, so yeah, happy to be here. Happy to have you. How are you?
Same. I'm good. Just like excited for all the big fixes and stuff. Of the numbers are just genuinely amazing that we're able to like fix and make that kind of an impact. So I'm like psyched about it. This is great.
I want to go back to the previous hour, and I had my own rogue competition for the last 30 minutes to say if you have a number of if you have a developer joke, because I wanted to brighten up the morning. If somebody had a good developer joke and I find it good enough, like I will pick one to have an extra T-shirt. And if it goes outside of all the channels of the Big Fix, I will send it personally. I don't mind. And this was the winning joke. Do you know the answer? Maybe you've seen it.
Oh, I've seen that, dude. I was
Yeah.
watching.
Why do coders prefer dark theme? And Steve and I
course.
were discussing about it. We didn't have any clue, because light attracts bugs. So this will be the winner, and I want to ask that person to go to my personal Twitter account or to the Snyk Twitter account. I think my personal Twitter account will be better, so I don't bother all the folks. And my personal Twitter is, so feel free to follow me.
And you had developer Steve back then as well.
This is my Twitter account, but Shay, go there and leave me a DM with your where I can make sure where I can send the T-shirt, so I can actually make sure that you will get the T-shirt. So thank you so much. But yeah, big shout out to Liran. Big shout out to all the folks that were on the APJ track. And Liran, you're here to introduce me to a ton of vulnerabilities with Node, probably.
Yeah. And can I do JavaScript jokes as well? I was googling them.
You can do, like, while I'm on board, you can do any jokes. You can even make fun of my Java jokes.
I would never do that. I'm a nice person.
Don't you do that all the time. So no worries. You can even do that live on stream when everybody is watching. No worries. But come on, give me a joke.
All right, I was googling them, so like this isn't mine. So do you want to hear a JavaScript joke?
Yeah, sure.
Okay, I'll call back later. I'll call back. Okay, let's see what else is here.
They're a bit lame, but yeah. Okay.
Let's see. Only thing you can't install is Brain. For everything else, there's npm. Okay, that's okay. Let's see what else. No, another callback and promises. There was something with people going outwards. Like, let's see. Oh yeah. And the bartender says success, but you're not ready. So a JavaScript function walks into a bar. That's it. That's a joke. It's asynchronous. I did enjoy that one a bit, although.
Yeah, sure. I know. But yeah, you never know what kind of type it is anyway. So.
Exactly. And I knew you would come up with that one as well. There we go.
I always make type jokes. All right, folks. In the meantime, you know how the Big Fix works. We come back to that in a second. Feel free to tweet about the Big Fix using hashtag the Big Fix and the Snyk tag to make sure that we capture it. And once every 2 hours, we will pick a winner, because you automatically enroll into a raffle that can be that can win a prize.
Maybe.
Oh, one. I have to show this one. Gerald was like here, still looking for a joke. Knock knock.
Okay.
Who's there? Very long pause. Java.
This was a classic one at my previous
Gerald, you haven't run Java in a long time. Only the startup time is long. After that, we're super fast. But I get it. You're probably a C programmer, but feel free to come up with these questions. I love them. Make fun of us. Make fun of me.
What's the latest version of Java right now? What's like the JVM version? What's that one? Like 15?
17.
710?
17. Yeah.
Okay. Is it getting faster with
Now,
the new versions, or
no? We just pretend to get faster to have more versions. That's how we roll. I mean, it's still the same, but
that is so good?
we just bring up new versions, so it seems like we're rolling fast. But
True.
anyway, I will leave it up to you. You already have your screen shared, so let me pop that one in, and that is
Cool. I was like, what should we talk about? Because there's like so many things with, fixing and patching Node.js, the security side of things. And it's not just about like, I think the practical fixes, I mean, with Snyk, it's easy to do. And like you and Steven have been showing that all over the stream, but it's also about the awareness and like the overall problem that we have in the ecosystem. And I think software supply chain security has been something that's been on everyone's mind for a bit.
Yeah.
So, yeah, where does it meet you? Where do you find yourself with software supply chain? Is that like open source packages for you?
Yeah, I think for me it's open source packages and probably Docker containers, but open source packages because what you know is that you pull in something, but you're not sure what you're actually pulling in because most of these packages are frameworks or are bundled packages that bring in another that have their own manifest file that bring in another package. And if you do weird things for even if I'm talking about Java, for instance, with older Maven versions, you can even circumvent that it goes to the main central repository and goes to an alternative repository, and then you can have a package that's been altered with this. Well, you get where I'm going. That's been altered,
Yes.
and that some malicious code is in there, and you're not sure what you're actually looking at. You just blindly need to trust it, and I don't have any clue what I'm actually pulling into my application.
All right. Well, you like completely came running to a door here, like open door here, because I honestly totally agree with that. And I think this is just in time because someone was actually sharing like a blog article that we've written before in the past about log file security and how you could actually circumvent the whole promise of a log file based on that. So we haven't like even planned this. And I just threw up some slides here just to get the conversation going. But since you mentioned that, I'll bring this up and I want to make sure what it is. So Snyk log file security blog. Let's see if we find it. Okay, so kind of piggybacking on the Java story that you were saying, Brian, here's the thing is this is like a couple of years back. What we looked into as doing some security research is log files are usually used to like pin dependencies down. And this is actually so timely. So if you view a log file, like you make updates to your packages, whether a Snyk bot or someone else does them, you probably want to update the log file as well so that they are in sync. Because otherwise, if you just update the package JSON, if you're talking about JavaScript and NPM projects, what happens is you end up having that not in sync condition, and then the next person who just pulls in or fetches the Git repository and do an npm install, something like that, they actually modify the log file. So what you do is you commit the log file and the package JSON. But most of the time when you make like really significant changes to packages, or like maybe there's like a big tree of packages, the log file is kind of like pulled up in kind of like a collapsed mode, I guess. And so what happens is you don't see what is actually going on. So let me kind of roll this forward and show you kind of like what we did. So if I do expand it, kind of like collapse the diff, I kind of look at what's going on. So I've made this PR to this is, by the way, a real pull request ID to a project, and like they knew about this beforehand. But like this is what we did. So I've updated some packages. I mean, overall looks fine. I guess nothing to worry about, right? You can see it has like hashes for integrity and stuff like that. So like it makes sure that what you download is indeed the right thing and so on. But what if that diff had really just been hiding something? Like people don't even review diff files, but even if they do, they're like really long and like very machine generated. So like it's really hard to find anything. But you can see this diff, for example, where this MS package with a specific version is resolved from the npm.js registry, which is a trusted source. But I replaced it in the log file that I updated with my own version of a tarball that I modified and added the vector here. So if you hadn't like looked for this one and like collapsed the tree and looked for it and like really kind of like reviewed it character by character, line by line, you wouldn't have known about this. Like you just merged this in. The next person who did an npm install like on the team or a CI or something like that, if that would take place, they would actually install the MS version, and I could like put pre-install scripts there and some malicious code and whatever, and just like backdoor the whole thing without you knowing it. So I know we can like it didn't even like plan for this one, but I like that example that you gave about the sources of jars and stuff like that.
Yeah, but I think this is, well, I am not familiar a lot with, well, now I know that you use package log files within npm. However, I always found it, because you see that different ecosystems work in different ways.
Yeah.
Although in for instance in Java, it's possible to do these version ranges. It is basically uncommon, because what you get thought, what they teach you in school basically, or what is the best practice, is to pin it everything down, so you know that every time you build it, you have the same package. But isn't that the core problem with a lot of these supply chain attacks, that you actually don't really know which version you get pinged in? Because if I rebuild the same package.json, it can bring in other packages than the day before.
If you don't use a log file, that's what will happen. True. Yeah.
So that's what the log file is for. So actually, you're saying that if a commit is done, you should actually closely look at the log file to be sure what's actually in your application, not so much at the package.json, right?
In the in the log file, you mean?
Yeah, the log file. So the log file is technically what is really getting into, and the package.json is more or less the blueprint.
Yeah, that's kind of like why I think we titled this as like security blind spot, where because log files are supposedly helpful for you to like prevent those cases, but they're not always. Like if someone maliciously generates them in a different way, not what you'd expect. And there's like different ways of like the ecosystems now support. This is like from 2 years ago, so now we have like a bit more, I would say, better prepared for this. First of all, there's like this log file lint open source package that helps you kind of like lint this and say, I only want to accept entries into my log file from like trusted sources, for like from my npm.js, my Verdaccio local server, my whatever kind of thing. Or you could also do installs with npm CI. It wouldn't specifically prevent this, but it would at least help you figure out if there's like a drift between your npm package JSON to your log file, which is important as well. And also now you have npm with and the new versions of npm package manager, like the CLIs version. I think it's 8.14 or 8.15. Anyway, just use the latest 8 major version, because that one includes a recent fix to kind of like a broken npm CI functionality from before. But more importantly, it includes a really important added functionality, which is the minor ignore scripts, which means that arbitrary commands won't be running on your machine when you do an npm install. So like, random people on the internet cannot execute commands on your machine, which is a side thing. So that functionality existed before in the major 6th version of npm, but it was a bit broken in terms of like it kind of like broke the whole npm scripts lifecycle. So latest npm 8 includes a couple of really important fixes. This is one of them. So yeah, I mean, this is really timely and important for us.
So if you like, we talk about supply chain risks here. Can you briefly explain to me, like for people? I mean, I know what it is, you know what it is to a certain extent, but what is your definition of supply chain in this case?
Right. So let's talk about. I think I'll start with a couple of examples in the slide here, which is I think what people take for granted these days, right? Like some people may see this as new things, but for quite a few years, this has been these few slides will be kind of like what people took for granted. What are supply chain risks, and they were always kind of like related to open source dependencies in some way. One of them was typo squatting attacks. So this is maybe not the correct way to install CoffeeScript if you're still doing CoffeeScript these days, which is great. I have nothing against it. But if you are and you did npm install because you've heard someone say CoffeeScript and just ran that in, maybe this is not spelled correctly and you'd be installing a malicious package that someone deliberately pushed into the ecosystem of npm, and once to install it again, they are able to like execute maybe arbitrary commands or stuff like that. So this is one example of supply chain security. The other one is maybe malicious packages, not by typo squatting, like by you making the mistake, but maybe someone else is like trying to potentially trick you into installing something else. So for example, Fall Guys is, this is actually pretty recent. Let me kind of pull this up. This is from 2020. So, relatively recent, August 2020. Where Fall Guys is actually supposed to be kind of like a bit confusing because there's like a game API related to this. So like maybe someone wants to use that SDK, so they install this version, this package, and if they did, they would actually be installing a malicious package, intentionally malicious, that steals sensitive files from you, like maybe things from your related like Discord data and stuff like that, like credentials and APIs and tokens and stuff. So like you don't want to do that. The other case is the case of compromised maintainers. So essentially, for example, you could be getting into a situation where the package is generally trusted, like React, Express, EventStream. They're all trusted packages, have been in the ecosystem for for years, for ages. But what happens if someone else, right, not specifically the maintainers, but like someone else is able to get the account credentials for these accounts and publish malicious versions instead of the original one? So some of these cases are real cases that we've seen on the ecosystem with actual security incidents. Some of them are not. I'll explain the difference in a sec. So EventStream has been it's been a favorite of mine because I think it's been one of the most sophisticated attacks we've seen. It's been really delicately planned and executed via social engineering and trying to like trick a maintainer to trust an individual who is just trying to contribute, but they ended up poisoning kind of like the dependency tree, and essentially adding a backdoor that also specifically targeted a bunch of developers doing cryptocurrency. This is like from, again, 2 or 3 years back.
Quick question on that.
Yes.
Just to get things straight. If a package is published under a certain version number, 1.0.1, whatever,
Yes.
can people or can the maintainer republish that same package under the same version number? So say I will retract that package and I will repush the 1.0.1 once again, but with different code. Is that possible?
It's not possible, but there's an asterisk there. So generally, package versions are atomic. Once they're published, you cannot take them back. It's like a one-way thing, and if you need like a fix for it, or like it's malicious or whatever, you publish a new version.
Okay.
The npm team can retract packages back because of like specific incidents if they're getting called about this. And the asterisk there is, they have some. So in some situations, you are permitted to take back to like publish a package version 0.1.0.0 and then like remove it completely so it doesn't exist. The actual maybe they changed, but the actual cases that this is allowed is like if this is a new version that has been there for like, I don't know, less than 72 hours or something like this, and only then they're allowing it. I think for packages like EventStream, React, Express, they probably have some other like counter measures. So like you can't really pull them off because like people are now dependent on them or whatever, like whatever they check in there. But generally speaking, yes, those packages are atomic and you cannot republish the same version.
So yeah, that's good to know that your packages are atomic, and
Yes.
the only one who can in a normal situation, the only one who can unpublish a package or retract a package is the npm team. So if you, let's say, pinpoint your exact package, you know what you're getting into, right?
Yes. You have a trusted version.
You
If you
can
like
you have a
tested it.
trusted version. No, that's a good thing. I well, you know my opinion on ranges in version numbers, and I
Yeah.
think in general you shouldn't be doing that. But that's because I come from an ecosystem that it's not common. But I was just wondering this, so that's why I asked you. In the meantime, I want to like on a previous comment we made, and I want to keep this more on a live thing. It would be cool to have a CI pipeline, check the package lock JSON diff for whatever the resolved host and package name changed. I think that
Julie,
makes I
that's
think that makes sense.
yeah, it exists.
Oh, it exists.
That's a
Okay.
great stuff from Julie. This is basically why I then built log file lint, which I think maybe has, or maybe yeah, I don't know if I don't remember if it has a GitHub action. If not, you're welcome to maybe contribute it to the project. But essentially, that's what it does. If you just put those kind of stuff into, I'll make this a bit bigger, into your CI commands. You could have your, depending on your allowed host, what you want to allow. Is will actually, you can see how it's running. It's actually testing things out, and if something doesn't match, it will fail. And that's essentially, I think, the diff that Julie is talking about. Unless, okay, awesome, cool. Thanks, Julie.
So thanks for the comment, Julie, and well, you can brag about your thing now, Liran. No, I'm kidding. I mean, this is genuinely good stuff, and we need more folks doing these kind of things and thinking of these kind of tooling in general. But let's continue. I was breaking your storyline with my questions, and
No, awesome. This is all good stuff. So compromised maintainers have. So we've seen new cases, but before we jump into like the UE parser, which I think Suman was like a couple of streams back in the morning, Developer Steve's stream, he was like sharing that with UE parser. But even before that, so you see here Express and React, and I'm pretty sure that if any JavaScript developer is like watching this now, they're like, what did React ever was, maliciously whatever backdoored or something. So no, not exactly, but there was. So there's let me frame it this way. There's a technical steering committee member on the Node.js project, a TSC member, who was doing research a few years back on, he named it like weak npm credentials, right? Like maintainers, me, yourself, someone just using password 1234, or maybe they use a more complicated password, but it was actually leaked in a previous data leak, and like they're using the same password the same again, or maybe they added like an exclamation mark or whatever to it. All of those cases are real stories. Like just the example that I just gave you are real stories, and that member of the Node project is like doing security stuff, and they went on to do with full disclosure for npm this kind of research, and they did find. They were able to like get access to Express and React for some other packages as well, and for some packages multiple times over a period of time, due to the fact that just maintainers did not enable two-factor authentication. They had used a weak password. They had used a leaked password, whatever. All of those cases really happened. They were just like doing this as like an ethical hacker and as part of a research. And so they disclosed all of that information back to npm, and of course, things kind of like passwords rerolled, etc. So nothing bad happened, but it could have happened if someone had malicious intent. So this is a case we should know about. The other one is with UA parser. Is, I hope I'm not confusing that. There's been so many of them, COA and RC and some others, but I think it was UA parser JS. Am I? Okay, at this point, I found confusing that with something else. But one of those, yeah, Fran is like, too many npm packages, too many npm security incidents, and you're right. So one of those was compromised to have like a backdoor inside, like a Trojan thing. And I think one of the hypotheses was whether someone really gained access to them via like account takeovers, or maybe it was kind of like sold, kind of like to someone else. Like that's, by the way, a common thing with browser extensions, which gets me back into that first question of like, where does supply chain security meet you? And that's kind of like where we're going to go now. And so to me, so all of those cases that I've showed you now that we discussed are basically like kind of like what has been on the news with regards to supply chain security. Yes, maybe I install a malicious package, maybe someone backdoors, whatever. But actually, software supply chain is much, much wider than that. Let me get some ideas, okay? One of them is indeed extensions. Like you're using extensions, that's a software, that's a piece of software. As a developer, maybe you're using like a dev tool that helps you, I don't know, like take screenshots, like find colors on the page or whatever. If you install that extension, how much trust do you put in it? And how do you know that this extension is not doing, browser extension is not doing anything malicious on your machine, like stealing the websites you're, putting info into, etc. Like you don't know those kind of things. So that is part of software supply chain. And we take a lot of software for granted, let alone open source, but also software that's not open source, like we just installed them.
But it also basically means, for instance, let's say your IDE.
Thank you for bringing this up. Let's
Oh, this was serious, folks. This was not scripted, but I'm just thinking out loud. I'm just thinking out loud here that if you're working in an IDE, you trusted that the IDE will help you by clicking that button that actually builds and does the proper npm commands or whatever commands you're using. But your IDE can also be interfering with that, and for instance, putting in code or something like that.
Yes, exactly where I was going with this. Thank you for bringing this up. So this happened some 1-2 years back. I don't remember, 2021. Yeah. So you could just look it up. This has been a research that the security research team here at Snyk did, and it's been mind blowing in terms of what happened there. So maybe you haven't heard about this too much, but this is super important to know. So if you're using VS Code, I'm with you. I use VS Code myself as well. I know Brian doesn't, so like maybe he's like a.
I do. I mean, I actually wrote extensions for it. I mean,
you did.
Together with some other folks, we wrote the Vulnerabilities, which is now deprecated, but I know how easy it is to.
It's not deprecated. It's integrated into the product. That's actually an amazing success.
That's Vulnerabilities itself as a project is now deprecated because they lifted all the stuff and put it in the Snyk thing. So we have even more great stuff in it.
That's how good it was.
Yeah, but the point I wanted to make, it's super easy to publish an extension either for VS Code, but for other IDEs as well. It's like, I'm not sure if anybody is actually checking. Maybe not, or maybe some automated checks. But I was just mind blown that it was so easy to publish an extension.
True, it is easy. npm.js is also easy. I'm pretty sure some other ecosystems are very like, because this is kind of like the spirit of open source and like collaboration, like just enabling an open ecosystem. There aren't a lot of checks. But yeah, so I mean, back to the story here, right? So I'm using VS Code myself. I definitely have some extensions there. I'll admittedly say I like do not significantly review like the code of pack extension that I'm installing on VS Code. Like I think I have some Git extensions like Markdown preview or whatever. And I just know they're on the marketplace for VS Code, so I just install them. I follow those 10 best extensions, amazing extensions for developers articles, and I might install one of them. And that's kind of like what happens. So here's the thing. This research actually went on and found that some VS Code extensions, they're not malicious, not at all. They're like amazing, open source packages and code maintainers behind them, but they have vulnerabilities. Now, here's the kicker, right? Like, well, what kind of vulnerabilities can you have in an extension that would be significant for a user as a developer using it? I mean, like, I'm not pushing that vulnerable code into production or something. You're right, that doesn't happen. But some extensions, if a specific attack vector allows interacting with them, they actually put you as a developer using VS Code and that extension enabled in your IDE in a bad position. Now, kind of like cutting the story short here, I'll go with Markdown because I have a Markdown extension. So if you, for example, install this instant Markdown extension, which has way over 100,000 downloads, so it's like pretty popular. What it does, obviously, like we all do Markdown, so you edit the README. You maybe want to like have a side pane with the preview of it. So that's what it does. But the thing is, to do that, it actually spins off an HTTP server behind the scenes. So like it does that. So like it can render the generated HTML from the Markdown parsing part. And that is like that HTML report, service regenerated view is what you actually see in the pane. So, I mean, that doesn't sound harmful at all, except this security researcher at Snyk was like, oh, okay, so they have spinned off an HTTP server. Let's see what we can do with it. And apparently, that HTTP server, you could trick it into potentially having things like path traverse and vulnerabilities. Like, instead of fetching the generated Markdown, I could actually fetch your .npmrc file and get all of your tokens if you're like a maintainer. Or I can get whatever other, from, I don't know, your .ssh, security keys, PKI stuff from your machine. All of those kind of stuff, I can have access to them. So that's like pretty mind blowing. I don't know if like the video will play well. I think we've kind of like embedded a video here, and there's like an example of how all of this stuff, how it works. I would actually read way through this, and this is just, I think, like my blog, which is a bit of like somewhat rephrasing the whole research, right? There's like links at the end for the whole deep dive research from Kirill and Raul on the team. And some of this attack vector exploitation is actually not that trivial. I remember like reviewing this with Kirill, and like you kind of need, sometimes because of cores, you can't really make the attack as if you had wanted to be like as simple. So you have to like generate, there's a request that actually downloads an HTML file. That HTML file is being served. That HTML file has an iframe in it. That allows you to download something. It's like a complete inception kind of feel into it. So I totally recommend going deep dive into this. And so I don't know, like if this video works, let's say. We don't need sound, but I do wonder if like video will play well. So here's Instant Markdown. It's open. You can see like the view, and then like Kirill has this three. Maybe I'll explain like during the thing because it's really fast. Three terminal windows. One of them, they are like serving a script to like see that there's a request coming in, and one of them showing you kind of like on the left side, showing you the terminal, like the status of the files. And the other one, they're just like doing the curl commands. So let's see. This is ngrok and PHP. So, okay. So basically, to trick you, how do I make this? How do I exploit this functionality for you? Like, how do I attack you as a developer? All I need you to do as a developer, if you have this extension or maybe other vulnerable extension that we've listed there, is to click on a link. That's it. As simple as clicking whatever link I send you. Twitter, Reddit, I put it as a Stack Overflow comment, whatever you want. The moment that you clicked on that link on your machine, or you have VS Code running and open, that's where it's game over. And that's what we're seeing here. This is basically now Kirill clicking that link for ngrok. That link says, nothing to say, like, nothing really important happened. So maybe I just ignore this, don't do anything else. But you can now see that do we see it? The extension keys, I think Kirill was like reading them or writing them. At this point, I don't remember it at all. But extensions, so like extension keys before weren't even existing, and afterwards, I think we have like this YAO 1F whatever thing in there. So like we have access to all of those, kind of stealing all of those keys, and now they're there on his machine. So totally recommend going through this. Super interesting, and how to mitigate it as well. Oh, this is like a cool part, which once they've done this, I'm still putting this range. Like once they've done this, we've actually scanned one of those. I don't know if all of them, but some of them with Snyk, which is a SaaS tool, which is a static application security testing. So it basically runs on my code and checks, well, what's wrong with it, and tell me how to fix it if I have security issues. So that's what we did. So there's like also a CLI command to it, like the Snyk code test, and we kind of just git cloned the vulnerable, commit history of point in time of instant markdown, and it shows you that we were actually able to find that path reversal vulnerability. So essentially what I'm saying here is, if you, as the developer of VS Code instant markdown extension, had used Snyk code in your IDE and you kind of like have seen it and fixed it, you could have like completely avoided this whole mess. So please use those tools. Like that's what they're for. Like they're integrated in the IDE. It's like an amazing example of like how this could have been prevented. There's like, oh yeah, we've done a video on this as well. So like this is pretty cool. And Kirill walks through like the whole deep dive research. And there's also like, if you fancy reading, there's a bunch here into the top one. So yeah, supply chain security with Node.js, NPM, and all of those stuff. A lot of fun stuff.
But it's interesting to see that supply chain goes way further than just your dependencies brought into your own application, like the browser, the IDE, all these kind of things that interact with your application or your code can be a factor as how to get breached. So, but what do you think are solutions to arm yourself against supply chain risks? What would you say? Like, okay, I now see that we have a ton of problems, but problems are there to be solved. So what should I, as your Joe average developer, what should I be doing when I'm developing my next application tomorrow? Well, not tomorrow morning, but maybe on Monday, to defend myself against supply chain attacks.
Yeah, so supply chain attacks is, like we said, it's pretty wide. It's anything from like you wouldn't think of your extensions being vulnerable and putting you at risk to your extensions in the browser, right? And everything in the middle. And so I think what we're trying to do as a community for application security, and there's like different initiatives on the OpenSSF, the Open Source Security Foundation. OWASP has some links on them. It's basically giving people a framework and kind of like guidelines, like best practices. So, you could go any of those resources or on like the Snyk blog or stuff like that and just look things up, because we've written a lot of guidelines on how to do things correctly. Like some of them are literally as simple as having two-factor authentication enabled. Like you are as a developer, maybe today you're just a developer not publishing any packages to the ecosystem, but maybe in 2-3 years you will be, and you will forget about enabling 2FA back then. So do it now. Act with importance and due diligence to all of the stuff that you're doing and how you may affect and be part of this ecosystem. So it's things like that. It's things like having secure defaults. So your NPM, for example, when you install things, you do npm CI, not npm install. You do not allow drifts to be made on dependency resolutions. You have secure installs, like you're not allowing arbitrary commands to run as an install for npm. Please do not. Oh my god! I can't stress this enough. Please don't do this. And use secure defaults. NPX, use it wisely and securely. NPX is like a way. Brian, I don't know, like if you've used that before too much. I probably heard about it a bit. It kind of like allows you to spin off commands. You know this? Have you used that one?
I have used it once or twice. Yeah.
Okay, cool. Yeah, it's not that common. I don't use that commonly either. It's kind of like when you want to like spin off, one-off things. But what it does is if you do like npx, I don't know, create React app or something like that, which is package on the ecosystem, but you don't have right now create React app installed, it will go fetch it, download it, and run it. So essentially, it's like how we were telling people from like maybe 2 decades, not 2 years, 2 or 3 decades. We were telling people, do not click on random links on the internet. Do not execute, if someone sent you an ICQ or IRC.exe file, do not run it. There's nothing cute in it.
And
Don't
that's
worry.
basically what you're doing, because you're blindly trusting that whatever you're about to run with npx, you just run it. There is no,
Yes.
well, maybe you can run it in a container with limited privilege or something like that to try it out. But yeah, if you just do it on your machine where you are the admin, good luck.
Exactly. So, be careful of those things. Be very mindful. I think that's, being aware of the problem, like they say, like in medicine and every other field, like 50% of the solution, right? Like just be aware, be a bit more, doubtful when you kind of like need to put it out, because it's your CI, it's your dev environment, it's your GitHub Actions. By the way, GitHub Actions, like, are you? I don't know how people use GitHub Actions today. Like, they're a wonderful thing, but for example, you're essentially just using someone else's action source code in your CI. What happens if whatever malicious attacker takes over
That's the
their
same.
source code?
That's the same thing if you just spin up a container, because the first thing that you do is say from,
True.
and you pick a random base image from Docker
Yes.
Hub, for instance.
Exactly.
Like which one did you pick? But then you go back to all the way into your own dependencies to like which dependency did you pick? How many maintainers has it? What was the last, like? And
that's why this discussion, I totally agree. This discussion always goes back and ends with that article on reflections on trusting trust, which I like always kind of like getting back to, because like it's, Ken Thompson, 1984, writing this and saying, hey, I backdoored, the Unix login C program. Oh, you found it? Okay, cool. I'll backdoor the compiler that builds the program. And oh, you found the code in my compiler? No worries. How do you compile compilers source code? You use another compiler. So what he did is like he ended up going on and like backdooring the compiler that compiles the compiler, and in that code they added the backdoor for the C for the login C program specifically. And it's like it was like an experiment that shows you that it's a matter of trust. Like you have to trust someone, you have to trust yourself, you have to trust that my keyboard here doesn't have a keylogger in it, hardware chip or whatever. You have to put trust somewhere. The thing is, if you don't trust anyone, you will start building everything on your own, everything from frameworks to whatever, and we don't want to do that either. So the middle grounder is figuring out what risks you should be taking, what risks are okay to take, because it's all about risk mitigation and trade-offs, and also just knowing, I guess, to an extent, what guidelines you should follow, what best practices, how do you limit the blast radius of something if something goes bad and wrong.
A completely other question. It's about supply chain, but what you hear about, like, I went to a few of these security conferences where you see people in suits talk, not so much the developers, but the folks that are in info security, and those folks do have a ton of knowledge. But I heard more and more people talking about SBOMs or how do you say that? Software bills of material, as well. It almost feels to me like they see that as the next step to inform everybody what you're actually using. What is your vision on these software bills of material? Do you think it's something useful, or do we see it too much as a silver bullet? Or tell me about it.
Yeah, I mean, it's important, right? It's like a very important step. Just knowing what you have, your inventory, is important. So let me show you what SBOM is from like the Snyk perspective to it.
I will pull up your screen again.
By the way, dude, I just want to tell you that I've prepared an entire demo walkthrough. I have like the IDE open, MongoDB open, but we can like completely went off script here with a bunch of stuff.
You said to me earlier, like, let's have a talk, and I'm just genuinely interested in what you had to say. So I'm just making up questions as I go.
No,
so
I love
this is what I find the fun part of a live stream, that we can blow. But let's go into that SBOM, and then whatever you want to tell. I will shut up for a second. That's maybe a good thing.
Cool. Because I did want to show something, but yeah, so we can get to it at the end. What else? Okay, yeah, S-bomb. Okay, completely distracted. So this is the Snyk version of this thing, right? Like I've opened this Goof app, which is a vulnerable Node.js app, which maybe you've seen before or not. It's open source. You can play with it. But the way I think of it, right, from a very software defined perspective of my specific application dependencies, is I can go here, right, and watch all of my dependencies. This is my software bill of material for building Goof, right? I use this package and this package and this package, and these are the versions. And it's not about the security vulnerabilities that they have. Maybe I'm just using like too permissive licenses that are not compatible with the way that I'm building software. Like if I'm using GPL and distributing software and also like making changes to it and like integrating that with my app, then I may be in violation of the license, etc., etc. So this is my idea of it. You can of course like filter this by direct, transitive, all of this stuff. Oh, this is pretty cool. You could have health perspectives to it, like let's see if yeah, so like what does this says? Package version is deprecated. So my Goof app actually uses. Actually, didn't know this one before, Brian. It's like quite a bunch. Like I thought it was a few, but I know request is like super popular and has been deprecated for a couple of years probably at this point. But it's like last published also like resolve URL. This was like last published 2014. Now the thing is, it probably still works and like amazingly well. Great. What happens if someone discovers in that code base a security issue tomorrow? And I've actually no idea who maintains this, but if they're not responsive or it will take them time or whatever, or like at 2014, probably I don't know if the CI even works and like they maybe have like expired accounts, etc. So it might take them time to do security releases, like a bunch of stuff that again relates to software supply chain. So knowing all of those things in advance kind of like helps you put some limitations and thresholds on those things. And like this is just viewing it. You could of course view it by a tree, which is a nice little view to just say, well, these are not just dependencies; these are nested dependencies. So how do they impact my application? I see we don't have any license issues here, but definitely some vulnerability issues. So this is my take on S-bomb. I like that you asked that question because I'm like researching some stuff for like a content that an article that I'm building on this, and I was asking one previous question on this before on Twitter about like, well, it's not just about my application as like my dependencies, but also as a software bill of material. I actually do a lot in the application. I have like we just saw this when I imported the repository. I have my Docker file and I could have my Terraform, and that may define resources on maybe AWS that I have running. So I want like this full visibility of my application and everything that's like is needed for it to run, not just what I have into like my own source code or whatever. So I think so like that I was kind of asking that, and someone did reply, and I learned something new. Or I think they said there's like so I don't have the exact URL for this, but if you search for, so there's more, S-bomb is actually more than just software. It's like all the resources on the cloud. It's like hardware. It's like a bunch of stuff that is a lot that is possible to define. And there are different there's like CycloneDX and some other ways of like standards of like how do you define all of that. I guess in a nutshell, like kind of like answer here, this is important. It's super important to be able to like take actual action to fix those things as well. Also, just knowing what you have is important.
Yeah, I couldn't agree. I couldn't agree less. I mean, I couldn't agree more. And it's absolutely super important. But I will leave the last 9 minutes up to you because you had a demo prepared. So now I'm curious.
Yes, right.
Show me. Come on.
I don't know how much we'll get to the demo. Let's see how we get to it because
sure.
But I was looking at, so we have the goof up as we said before. Let me just take this a bit down, and there's like an open redirect dependency issue that we have vulnerability issue that we have in one of the dependencies in the goof up, which we can talk about. But what I was thinking, you know what, I actually want to look at the database that we have. So Snyk, if you go to like security.snyk.io, and we change this a bit, and we can like show you a few of the ecosystem that we support, and you can search it. And there's like very recent or popular vulnerabilities last week. But if I go specifically into npm, I'll just search npm and then is like my way of getting here. I'll clear this up for a sec. You could see all the database results of like, this has been disclosed like, earlier this week, like prototype pollution in embodiment, which I have no idea what it says. URL parse, of course, I know, etc., etc. But I noticed that there's open redirect in URI.js just disclosed earlier this month. Like, this is like a couple of weeks back. And so I was like, okay, now there's like something very, practical to talk about and like really valid from the news, right? Like it's not just like doing some pre-made demo on this. So open redirect. So essentially what it is allows if you're not really safeguarding the URLs that you're using in a way. For example, someone gives you a URL to the GitHub repository, and essentially you're like treating it in different ways. Like maybe you need to like git clone it or whatever, and you need to validate that this is a valid URL. Like it's not the URL to your machine's localhost or whatever else, so they can do different weirdy things that you don't want them to do. So what you should be doing is so not allowing this open redirect is like basically mitigating those weird URLs resolving. So you may use a way to work with URLs called URI.js. You may use this package. Now let's deep dive a bit into what it says. So the references are really helpful. They give you the commit and the GitHub PR. So here is the commit for the case here with open redirects, right? It tells you, so this is, by the way, from like 10 days ago, right? So like we said, like super relevant. Someone opened, this is actually the fix, right? So fixing case insensitive scam. So we see a test case below. This is the minified version for the browsers. And yeah, so essentially just a test case, and we can learn some stuff from it. Like what would someone maybe try, and hopefully like it gets sanitized or caught. So let me go open this here. We have this. And what I want to do is basically realize that this is a single character command, diff, that was like the regex apparently is supposedly working or has worked before. But what was missing is that it wasn't checking all the cases, like case insensitive flag here with the I was actually what would have helped prevent someone from giving you a capital case of HTTPS or FTP. So I actually went in and like dived into this a bit more, and then I went into the PR, so the pull request for this, and then someone said, "Hey, this is a fix for a previous security vulnerability, right?" So let's look into that one. Now I can actually look at it because this is now made public. And thank you, Rodney, who maintains this software package and released the fixes so fast. So this is what happened before. So bypass for URI.js. URI.js fixed the issue, blah, blah, blah. However, an attacker can still exploit the issue due to case-sensitive checks in earlier. So here's the POC, right? They give you, this is the way that you use the package. You require it. Then you say, this is something coming from user input, right? So someone can give you a GitHub, like maybe you're doing GitHub stuff, so they give you a GitHub URL. Maybe they give you pictures of URLs of pictures and images, and like you need to fetch them and I don't know, like convert them or whatever. So anything to do with URLs. Now, if you gave it the capital case and you did, ///, what would happen? You can see the output here is this, like the slash part here is now being regarded as the actual path, not the domain. So like if you had a check, that's like, okay, let's check that if URL is actually URL.hostname, because this is an object, is not empty or something like that, then this is a valid URL or not. So like you would be able to trick someone just by giving them kind of like a confusing URL. The library has the bug in it, which it thinks that this is a relative URL, while this is very much the way the browser, by the way, treats them is an absolute URL. So the browser is okay, but the validation is not okay. Now, where this takes you is it actually opens a whole slew of server-side request forgery issues, because if you then did something with that URL and that you thought to be relative path, right, versus an absolute path, what would happen is the following. Think of like if I'm just giving you this kind of URL, right? Localhost, 5,000 users. Maybe that is something that I know you have running. Maybe it's like AWS, whatever, cloud front, blah blah blah, and I'm stealing all of your account keys at this point, right? Because I'm actually able to make that request, like you are making that request because I told you to fetch, the GitHub.com, but it's not the GitHub.com. You thought it's like a relative URL, but it's not a relative URL. It's an absolute one. You fetched it, you got a response, you sent it back to me. Now I have like environment APIs, whatever, all of those kind of things.
I think that's interesting because there is no one description of what a URL is. I mean, there are certain ways to interpret URLs or URIs or back URLs. I was watching a live stream some time ago with the maintainer of curl and what the problems was that they had to face with. Yes, exactly, and that was super interesting, and that's basically what this is as well. Like, how do you interpret this? But because one browser interprets this differently than another tool or another package in a certain language. So I love this.
Yeah. And there's like different POCs. Like you could see if you use this. So if you take this and pass that over here, my browser will actually go to github.com/foobar. Like it should. Let's see if it does. Right? It goes to this domain because it understands this is an absolute URL. But the library doesn't. It still thinks it's a relative path. Like hostname is empty, right? So this is where bad things happen. Like there are like different examples of them. But the fix here was just as simple as basically adding a case insensitive to the previous fix. And the cool thing that I also wanted to show is we've actually would be finding this. So I have in the goof up this this redirect example where I just like show this off, and it has this open redirect issue in it, which the SAST IDE kind of like found for me and told me that I have an issue here and I should probably fix it before something like that happens. Anyway,
you should. You're a security engineer.
I know.
You should. All right. Thanks, man. This was super interesting. I mean, we went way off script as in what we actually we're talking about, but I think we managed to keep the attention of everybody who is here, and that supply chain attacks are a thing, and we should take responsibility and look at things more than we are doing now. But there are a lot of you made me a bit scared, to be fair. Like, and now I'm now have to investigate what kind of stuff I'm running in my IDE and in my in my website, or what a kind of plugins I'm running, etc. etc. I love this, Liran. Thank you. I appreciate this so much. So
thank you for having me. Have fun.
Let's do this once again and talk more about this during a Snyk live session. That's basically on Twitch as well. If you're on Twitch or on the Snyk YouTube, we do this every once in a while with a more open session, like we did today. Like, not so much scripted as a presentation, although presentations are cool as well. Don't get me wrong, but I love that we just wandered off. If you want to follow Liran, go to his Twitter account and please give him a follow. I mean, he's an awesome guy. Not just saying that because he's my manager, but I honestly believe that. GitHub star, so he's honestly a big example for me. So, Liran, I want to thank you because I see we have the next speaker already backstage, and that is Sarah. But before that, I need to do some shout outs. So, Liran, thank you for being here. I appreciate that, and I know that you will be backstage, and see you in a second.